Hello all and welcome to the Algebra video for Algebra Lesson 3, okay? And this is going to be on Chapter 1, Section 3, which has to do with the properties of numbers. Okay, and just so everybody knows, this is starting on page 16 in the book. And what we've got here is, and this is a pretty tough section to get through because there are a total of 11 properties that we have to go over here, okay? Now, with all these properties, some of them are going to look very similar, but if you pay attention to the words that I use to talk about each property, okay, that will allow you to know, based on what the property is called, what the property is going to mention or what the property tells us about different numbers and things like that, okay? So the first thing that we got to talk about in this section, okay, is that equivalent expressions represent the same number. So what we mean by that is all these expressions that we've talked about before in sections 1 and 2, if they are equal, so that's what the word equivalent means, if they are equal, that means they are the same number, okay? So each side is equal, meaning that they are the same number. They represent the same number or value, okay? Now, with that being said, all of these properties that we're going to see here, they have equal signs in them, meaning anytime you see an equal sign, okay, that means what's on one side is equal to, and it represents the same number as what's on the other side, okay? So to start off the notes here, okay, the actual notes, so let me draw a little line here to separate, because now we're going to actually get into the properties here, okay? So the first properties we're going to talk about are the properties of equality. So all of these properties have something to do with something being equal to something else, which, like I said, all of the properties technically do. But in this case, this is telling you how we can use equal signs to talk about different properties of numbers here, okay? So the first property we're going to talk about is what we call the reflexive property. Okay. Now, when you think of the word reflexive, okay, what I want you to think of, so this is the same thing I'm going to do for every single property. When you think of the word reflexive, think of the word reflect, okay? So the way that I describe this one is, if you look at yourself in the mirror, you see your reflection, okay? So what the reflexive property is going to tell us is when a number looks across the equal sign, it's going to see itself. It's going to see its reflection, okay? So what this property tells us is any quantity is equal to itself. Okay, so if you've got something on one side of the equal sign, this property tells us that it's equal to itself. Okay, so the way that we say that in terms of symbols and math is we say for any number A is equal to A. Okay, so once again, think of it in terms of a reflection. When the number A or the expression A looks across the equal sign, it sees itself. Okay, so some concrete examples of this are, well, 5 is of course equal to 5. And you might say, well, duh, 5 equals to 5. But that's a property of numbers we call the reflexive property, is that if something's on one side of the equal sign, then it's equal to itself on the other side. So once again, think of it as kind of like a mirror here. A number sees itself. It has a reflection. It sees itself. Okay. But this also works with just expressions. So if we have 4 plus 7, okay, well, that's the same as 4 plus 7. So if something's on one side of the equal sign, it's equal to itself on the other. And that is the reflexive property. And this is honestly one of the easier ones because, once again, if you think of the word reflect, when you talk about reflexive, once again, you've got something on one side is equal to itself on the other. Okay? Now, the next property of equality, let me erase that. The next property of equality that we have is called the symmetric property. Okay, and what the symmetric property tells us is if one quantity is, or if one quantity equals a second quantity, then the second quantity equals the first. Well, in this case, in terms of the words there, it can get a little bit messed up and a little bit hard to understand maybe from the words that we're using here. Okay, so when we have the same thing here, when we talk about it in terms of symbols, we say for any numbers a and b, a is equal to b. So if a is equal to b, then b is equal to a. And this property allows us to flip things across the equal sign, okay? So if something's on the left-hand side and it's equal to something on the right, then if you flip those things over the equal sign, it's still true. The second thing is also equal to the first, okay? So when you think of the symmetric property, we need to think that we're going to flip, okay? So when something's symmetric, if you flip it over, it's still symmetric, okay? So the word symmetric means that one side is equal to the other, okay? Well, if something is symmetric, then if you flip it around, that first side is still equal to the second side, okay? So it doesn't matter whatever side it's on the equal sign, it will still be equal, okay? So an example of this is going to be, well, if 8 is equal to 2 plus 6, which is true, then 2 plus 6 is equal to 8. So both of these say the same thing, it's just we're flipping across the equal sign, okay? So this is a property we're going to use a lot when we're solving equations, okay? Because sometimes we'll need to flip whatever side the variable's on, so that way make it a little bit easier for us to work. But the symmetric property allows us to do that because it says if one thing is equal to another, then if we flip them across the equal sign, that still holds true. This is still equal to that, okay? Now, the next property, this is probably one of the most difficult ones to get through, because once again, when you look at the words, there's a lot of words here, and it's easy to get mixed up with this. But this property is the one we're going to call the transitive property. And what the transitive property tells us is if one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity equals the third. Okay? So once again, all these words, we're introducing three quantities now, okay? But what I want you to think about when you talk about the transitive property, think of the word transit. Okay? So when you transit on a bus or a train or the subway or in a car even, okay? That's what I want you to think of when you think about the transitive property, okay? I'll talk about why we need to do that right now, because when we look at the symboled version for any numbers A, B, and C, if A is equal to B and B is equal to C, then A has to be equal to C. Okay? So the reason I want you to think of the word transit is think about a train. If you're on a train and you get on at stop A, okay, and the train takes you to stop B, and then from stop B you go to stop C, if you go from A to B, then from B to C, that's the same thing as just going from A to C. So once again, if you get on the bus at stop A, then you stop at stop B, but then you go on to stop C, like I said, technically you're going from A to B, then from B to C. So, but instead of breaking it up like that, you can simply skip stop B and go from A to C. Okay, and that's what you're talking about here when you are doing the transitive property, is that if you start off with A and it's equal to B, so you've got two different expressions here and they're equal, okay, but then you have that expression B equal to another expression C, well, we can kind of cut out the middleman. We can cut out the B and just say, well, we know then that A is equal to C, okay? So once again, we can skip over this middle stop and just say we're going from A to C. So for example, okay, if 6 plus 9 is equal to 3 plus 12, and 3 plus 12 is equal to 15, we know that equals to 15, then we know that 6 plus 9 also equals 15. Okay? So once again, we start off with something and we know it's equal to another expression, but then we know that second expression is equal to a third expression. Well, then we know the first expression is equal to the third expression. So once again, we know that A is equal to C. So once again, we can kind of leave the B behind. Okay, we don't need the B anymore because now we're worried about what's happening with A and C. So once again, if you think about it in terms of transit, think about it in terms of the train analogy here. You get on at stop A, you go to stop B, but then you get off at stop C. Well, instead of saying you went from A to B, then from B to C, you could simply say you just went from A to C. Okay, you got on at stop A and you got off at stop C. We didn't have to mention that we stopped at stop B because that didn't really pertain to us, okay? Now, if we didn't have stop B, well, then we wouldn't have the train set up in the way it was. So the B is necessary here, okay, to let us know that if A is equal to B and B is equal to C, then once again, since those are connected, then A has to be equal to C. Okay. Now we do have one more property of equality. Okay. And this is probably actually the most common property that you will use, okay? You've been using it actually in the last section, section 2.1, so section, or 1.2. You use this property pretty much in every question that you answered, okay? And this is the property we call the substitution property. And what the substitution property tells us is a quantity may be substituted for its equal. Okay, so when you think of substitution property, I want you to think of the word substitute or replace. So when you substitute something, you replace it. Okay, so when you substitute something, okay, that means you replace it with something else. Okay, so in terms of words, if A is equal to B, or in terms of symbols here, if A is equal to B, then A may be replaced or substituted by B in any expression. And where you've seen this, okay, so a good example of this is when we've had to substitute in for variables when we're doing order of operations, okay? So they'd say if n is equal to 11, then 4n is equal to 4 times 11, okay? So you can take wherever n is in the expression and replace it with the 11, okay? So once again, you take the 11 and you put it in for every n that you see in the expression. And that's actually an example of the substitution property. And when we look at some of these other examples, we will look at how those properties work in terms of just evaluating expressions, because that's actually the first example we'll look at today after we get through a majority of these properties is how we use the substitution property in everyday evaluation, okay? So after the substitution property, we're going to go on to what we call the addition properties. And as you can probably guess, the addition properties are going to be properties that involve addition, okay? So notice up to this point, we haven't really talked about any operations. We've just said something is equal to something else, okay? Or in the case of substitution, if we know something is equal to something else, we can replace it with whatever that is, okay? So there's actually two addition properties, and the first addition property is what we call the additive identity. Okay. And the additive identity property, what it tells us is for every, which let me go down here. So I want to leave a little space underneath the additive identity there. For any number A, the sum of A and 0 is A. So once again, in terms of word there, we need to know what the word sum means, which means addition. So what this really means is A plus 0 is equal to A. So when you think about the terms additive identity, well, once again, the word additive means we're going to be doing addition. And then when you think of the word identity, you want to think of keeping the identity or keeping your identity. So keeping the identity. Okay, so we want to add something to where the number keeps its identity. Well, the only number we can add to something to make it keep its identity is the number 0. Okay, so since that's the only number we can add to something to keep it the same, we call 0 what the property is called. We call it the additive identity. Okay. And basically what this property tells us is we can add something to anything and it keeps its identity. So for example, if we have 2 and we add 0, well, the result is still 2, okay? The 2 kept its same identity. We didn't change the 2 at all because we added 0, okay? So once again, this property just tells us we're adding something to keep the same identity. We're adding something to keep the same identity. We want the number or the expression to stay the same. And what that is the additive identity of 0. If we add 0 to anything, okay, we could do another one here. 5 plus 0, well, that's equal to 5. The 5 kept its identity, okay? So like I said, if you think about the actual words that describe the property, additive identity, the operation is going to be addition. And we need to think, well, we need to add something to keep its identity. We need to add something to keep it the same. In that case, that number is 0. Okay. Now, the second and last additive property, or addition property, is the one we call the additive inverse. Okay. So what the additive inverse tells us is any number and its opposite are additive inverses of one another. And once again, in words, that's kind of, it's using the term in the definition there, okay? But like I said, let's look at the words that we're using here. So additive, we know, once again, the operation is going to be addition, okay? And in inverse, we can see we got a number and its opposite. So you can think of the word inverse as meaning opposite, okay? So we're going to add the opposite. So what this actually tells us is if we have a number A and we add to it its opposite, in this case negative A, okay, opposite just means the opposite sign, that is always going to give you the additive identity, or 0, okay? So a number plus its opposite, a number plus its opposite equals 0, okay? And it works the same the other way around. So if we have a negative number and we add its opposite, that's going to be 0, okay? So for example, if we have 3 and we add to it negative 3, well, we have a number plus its opposite. That's always going to be 0, okay? And like I said, the same way, if we have a negative 4 plus its opposite, a positive 4. That's also going to be 0. So once again, think of it as adding the opposite. If we have a number and we add its opposite, it's always going to be 0. Okay? But I do want to make a note here is you get the additive identity out. Okay? So what I mean by that is the additive inverse and additive identity are kind of connected in one way, because if you add a number and its opposite, the result that you should get should be the additive identity. Okay, and you'll see actually the same thing when we talk about the multiplication properties. But once again, when you think of additive inverse and additive identity, the big feature here is the number 0. Okay, additive identity means you add 0. Additive inverse means you add the opposite to get 0. Okay, and we'll see some of this when we look at the practice and the homework. But let's go ahead and go to the next set of properties. Okay, and these are the multiplication properties. Now there's actually 3 multiplication properties we're going to talk about. Okay, and I'm going to start off with the easiest one. Okay, so this might not be exactly the same order that they do it in the book. Okay, so multiplication properties, the easiest property about multiplication is the multiplicative property of 0. Okay. So the multiplicative property of 0, if you actually just look at the words, multiplicative is going to mean multiplication is the operation. Property of 0. Okay. So in this property, we're just saying, well, what happens when you multiply by 0? Okay, multiplication by 0. So this property actually tells us for any number A, the product of A and 0 is 0. So all this property tells us, if no matter what number or what expression we have, if it's multiplied times 0, then it's equal to 0. Okay? And it says it right in the name. So multiplicative means multiplication. Property of 0, multiply by 0. Okay? And once again, what happens when you multiply any number by 0? You get 0. So for example, 9 times 0 is 0. Okay? Negative 6 times 0 is 0. So once again, any number that you have, if it's multiplied times 0, it's equal to 0. That's what the multiplicative property of 0 is. And like I said, if you pay attention to the name, multiplication by 0. Okay? The next multiplicative property we're going to talk about is the multiplicative identity. Okay? So once again, much like the additive identity, we've got the operation here is multiplication. And then once again, identity tells us we want to keep the same identity. So there's actually, just like there's only one way to add something to keep it the same, Well, there's only one way to multiply something to keep it the same, okay? And the number that we have to multiply by to keep something the same is the number 1, okay? So what this tells us is for any number a, so once again, any number, any expression we can think of, the product of a and 1 is a. So once again, what this is telling us is if we have any number and we multiply it times 1, we're going to get that number back out. So we can multiply times 1 to keep it the same. So if we have a number, we multiply it times 1, it keeps its identity. So multiplicative identity, multiplying to keep its identity, well, that means multiplying times 1. Okay, so an example is, well, if we have the number 14 and we multiply it times 1, well, it stays as 14. So we had the number 14, we multiply it times 1, and it keeps its identity. So 14 times 1 is equal to 14. Okay, so when we multiply times 1, that gives us the same number out, keeps its identity. So because of this, we call the number 1, just like we called the number 0, the additive identity. This is going to be the multiplicative identity. Okay, the number 1 is the multiplicative identity. And what this tells us is no matter what we multiply times 1, it's always going to stay the same. So any number we can think of to put here times 1 is going to be that same number. Okay, and that's where the identity comes in. It stays the same identity. Okay, now the last multiplication property we have before we actually will, after this we'll look at the first example, is the one we'll call the multiplicative inverse. Okay, now the multiplicative inverse, same kind of thing here. The multiplicative tells us that we're going to be doing multiplication as the operation, and an inverse, instead of thinking of it as the opposite, when we think of the inverse in terms of multiplication, the word I'm going to have you think of here is the reciprocal. Now, if you don't know what that word means, that has something to do with fractions, okay? So if you need to go back, which you'll see what I mean by reciprocal when we talk about it here in this example, but to refresh yourself on the word reciprocal, I'd maybe go back and look at some things dealing with fractions, because you're going to have to know how to multiply fractions here in order to do the multiplicative inverse, okay? But what the multiplicative inverse tells us is for any number a over b, so some fraction a over b, and then we have to have the stipulation where a and b cannot be equal to 0. Okay, and part of the reason we need that is if b is equal to 0, we'd be dividing by b, or by 0. We can't do that. And then I'll go ahead and tell you the reason we need a not equal to 0, because if a was 0, then this whole thing would be 0, and 0 actually doesn't have a multiplicative inverse. Okay, and you'll see why that is here in just a second. But we can't have a or b here be equal to 0. But if that's true, if you have that number, there is exactly one number, and that number would be b over a, such that the product of a over b and b over a is 1. Okay, so once again, a lot of stuff going on here. We've introduced fractions in a way here, okay? But all this is saying, so another way to say this is, if you have a number and you multiply it by its reciprocal, okay, you're always going to get the number 1. So in this case, A over B times B over A is always going to be equal to 1. Okay. Now, to show you where, so the reason A cannot be 0 is if we have B over A, well then we have the same problem here. We can't divide by 0. So that's why A and B can't be 0. And you'll usually see that when you've got a fraction. The denominator can never be 0. Okay. But that's the only stipulation we have here. Everything else holds. No matter what this number is, if we multiply it by its reciprocal, okay, so that's where the reciprocal comes in, it's always going to be equal to 1. So I think this will benefit you to look at a couple of examples. So an example of this would be, all right, let's say we had the fraction 4 over 5. Well, if we multiply it times its reciprocal, which is 5 over 4, well, then we get that that is equal to 1 because we have 4 times 5, which is 20, over 5 times 4, which is 20, and 20 over 20 is equal to 1. So let me actually write that out. 4 times 5 is 20. 5 times 4 is 20. And a number over itself, well, that's just the number 1. Okay. Same thing happens if you have whole numbers. So if you have the number 5, okay, well, 5 we can write as a fraction as 5 over 1. If we multiply that times 1 over 5, the same thing happens. 5 times 1 is 5 over 1 times 5, which is also 5, which will always give us out a 1. But I do want to point out that you get the multiplicative identity out. Okay, so what I mean by that is when we looked at additive identity and additive inverse, well, the additive identity was 0, but when we did the additive inverse, we added two things together to get 0. Okay, well, the same thing happens here with multiplication. Our multiplicative identity is 1. Well, in this case, the multiplicative inverse tells us we can multiply two things together to get 1. Okay, so just like 0 is the magic number for addition in terms of these properties, 1 is going to be the magic number for the multiplicative properties. Okay, so once again, multiplicative identity is 1, and multiplicative inverse, when you multiply two things together, you should get 1. Okay, so that's how all those are related in terms of the inverse versus identity properties. Okay, and we'll see, and we'll look at some practice with this right now when we look at the first example. Okay, and as you notice, we've only went over 9 of the properties. There's still 2 more properties to cover, but we're going to cover those before we do the next example. Okay, but let's go ahead and look at example 1. See exactly what we're doing here. So example number 1, this example is evaluating. So evaluate using properties. So the instructions here are going to tell us we're going to evaluate 7. Oh, put the parentheses in the wrong place. Evaluate 7 times, in parentheses, 4 minus 3, close parentheses, minus 1, plus 5 times 1/5. But then, so we have to evaluate that. So that's something like we did in last section, okay? But the new thing that they're asking us to do is to name the property used in each step. So what we're going to have to do here, so I'm going to rewrite this expression. 7 times 4 minus 3 minus 1 plus 5 times 1/5. And we're going to go down through here and we're going to simplify, or we're going to evaluate this expression. So that means using order of operations, okay? So the first thing we're going to notice is order of operations wise, we got to do what's inside grouping symbols first. So if you need to, write GEMDOS at the top of your paper. So you know what order we need to do things here. So now we've got to do the 4 minus 3. So we're going to do 7. The 4 minus 3, we're going to replace that with 1. And everything else is going to stay the same. But here's where we got to pay attention. And I suggest if you ever have a question like this, you do it when you do each step. So from here to here, what property did we use? Well, we went 4 minus 3 is equal to 1. Well, we don't have a property that tells us 4 minus 3 is equal to 1, or a number minus another number is equal to 1. So this is actually an example of the substitution property. Okay, and this is where we went 4 minus 3 is equal to 1. Well, since 4 minus 3 is equal to 1, we were able to replace 4 minus 3 with 1. Okay, so that's where substitution comes in. And honestly, most of these steps are going to be using substitution. Okay, but let's continue on here. So now we see we've got multiplication, subtraction, addition, and multiplication. So we need to do the 7 times 1 next. Well, 7 times 1 is 7. Okay. So 7 times 1 is 7. So from here to here, we do have a property that tells us a number times 1 is equal to itself. And that is the one where we have multiplication. So this is the multiplicative identity. Okay, and what shows us that is 7 times 1 is equal to 7. Okay, so we have multiplication, that means it's multiplicative, and the number kept its same identity. So 7 times 1 is 7. That's the multiplicative identity. So then we've got subtraction, addition, multiplication. So the next thing we've got to do is the multiplication here. And 5 times 1/5, well, once again, we can rewrite 5 as 5 over 1. We've got a number times its reciprocal. Well, we should know that that's equal to 1. And once again, or operation is multiplication. So multiplicative. In this case, it's going to be the multiplicative inverse property. And what tells us this is we did 5 times 1/5 is equal to 1. That's a number times its reciprocal is equal to 1. Okay. Now the rest of this is actually just going to be substitution. So we have subtraction and addition. We got to do subtraction first. 7 minus 1 is 6. Once again, we don't have a property that tells us a number minus 1 is equal to another number. So this is just substitution. And this is where we put 7 minus 1. We replaced 7 minus 1 with 6. Okay, we substituted in 6. And then, of course, the last one, 6 plus 1 is 7. So the answer here is 7, but then once again, we used the substitution property again. And in all honesty, every single step of one of these equations is technically substitution, okay? So if nothing else, if you've got substitution as a possibility, you're kind of always using substitution, but sometimes there's a more accurate property that can be used. So in this case, 7 times 1 is 7. It's multiplicative identity. 5 times 1/5 is 1. Well, that's the multiplicative inverse. But like I said, these other ones, 6 plus 1, we don't have a property that tells us a number plus 1 is equal to anything special, okay? In this case, we just have to go and say, well, we know 6 plus 1 is 7. So we can replace the 6 plus 1 with 7. So that is substitution. Okay. And in this case, you got to make sure to take it one step at a time. Okay. So going through here, taking it one step at a time. Okay. Going from step to step. Like I said, every single step there's a property being used, and most of the time it is substitution. But like I said, in some unique cases, like this 7 times 1 and this 5 times 1/5, there are other properties that you'll be using, such as multiplicative identity or multiplicative inverse. Okay. Now I will go ahead and tell you on the practice and homework, there's really no questions like this on your Google Form sheet. Okay. But it's still good to know how to do this. So when you're looking at this example, going step by step, okay, notice I'm only changing one operation at a time, and every time you change one of the operations, technically a property is being used, okay? So just remember that, just keep that in the back of your mind, that every time you simplify something or any time you change an operation, a property is being used, okay? But now we have two more properties that we've got to cover, okay? And these are ones that should be familiar to you. These are ones that you've learned about before, okay? The first one, the next property we're going to talk about is the commutative property. Okay? So what the commutative property tells us is the order in which you add or multiply numbers does not change their sum or product. Okay, so technically what this means is for any numbers A and B, A plus B is equal to B plus A, and A times B is equal to B times A. Okay, so if you know a little bit about the English language, commutative, okay, one definition of the word commute, and you can actually double check this if you type in definition of the word commute, one of the definitions means to flip. Okay, so to flip things in order, so to flip an order. Okay, so when you commute numbers, what you can do here is, well, if you're adding or multiplying them, it actually doesn't matter. A plus B is the same thing as B plus A. Okay, A times B is the same as B times A. It actually doesn't matter in what order you multiply or add things. The number's still going to be the same. So, for example, if you have 4 plus 8, well, that is equal to 12. Well, 8 plus 4 is also equal to 12. It actually doesn't matter which order you add those two numbers together, okay? They're still going to be 12. The same thing happens with multiplication. If we do 7 times 11, well, that's 77, okay? If you do 11 times 7, that is also 77, okay? So the commutative property, all it tells us is we can flip things around when we're doing addition and multiplication, and the result is still going to be the same, okay? So once again, think of the word commute, and like I said, it might be a little bit getting used to, but if you don't know the terminology here, the word commute means to flip things, okay? So when you commute things, you flip them. Now, the last property that we have to go over, so the last property we have here is the associative property. Okay. So the word that I want you to associate with the associative property is the word associate. Okay. So what the associative property tells us here is the way you group 3 or more numbers when adding or multiplying does not change their sum or product. Okay, so once again, in words here it might be a little confusing, but all we're saying by this is for any numbers A, B, and C, A plus B in parentheses, then if you add C, well, that's the same thing as taking A and adding it to the sum of B plus C. And it also works with multiplication. Okay, so if you have A times B and then you multiply C, well, that's the same thing as taking A and then multiplying it times the product of B times C. So one way to think of the associative property is with this term associated over here is if you have 3 or more numbers added together, it doesn't matter if you add the first 2 numbers and then the third number, or if you add the last 2 numbers and then the first number, the sum is going to be the same. Okay, and the same thing happens with multiplication. It doesn't matter if you multiply the first 2 numbers together, then multiply the third number, okay, because it's going to be the same as if you multiplied the last 2 numbers and then multiplied it times the first number, okay? So when I say use the word associate, it doesn't matter if you associate the first 2 numbers together or the last 2 numbers together, okay? In terms of multiplication and addition, the outcome is going to be the same, okay? So let's look at some examples to put a concrete view on this. So if we have 3 plus 5 and then we add 7, okay, well, order of operations tells us we would have to do the 3 plus 5, then add the 7. So 3 plus 5 is 8, plus 7, well, we get that is 15. Okay, but if we have the 3 and then we add the 5 and the 7 first, well, we've got the 3. Well, order of operations tells us we've got to do the 5 plus 7 first here. That's 12. Well, 3 plus 12, that is also equal to 15. So it doesn't matter if we add the first 2 numbers or the second 2 numbers. If all of this is addition, you're going to get the same number when you add all those numbers together. And like I said, the same thing happens with multiplication. If you have 2 times 6, okay, and then multiply times 9, well, order of operations tells us we got to do what's inside the parentheses first. So 2 times 6, that's 12 times 9. Well, that's equal to 108. Well, we're going to get the same thing if we do 2 times and then instead do 6 times 9 first. Okay, so in this case, 2 times, well, 6 times 9 is 54. 2 times 54 is 108. So once again, it doesn't matter which two numbers you associate with one another. Like I said, if they're in this order, 3 plus 5 plus 7, and the order of operations tell you to do the 3 plus 5 first, well, that's the same thing as doing the 5 plus 7 first and then adding the 3. So doing 3 plus what you get when you do 5 plus 7. Same thing when you do multiplication. So order of operations tells us we need to do the 2 times 6 first. Well, if we do the 2 times 6 first, then multiply times the 9, that's the same thing as doing the 6 times 9 first and then multiplying it times 2. Okay, so once again, associative property, think of the word associate. It doesn't matter which two numbers you associate together, the outcome is going to be the same whenever you're adding or multiplying 3 or more numbers. Okay. Well, let's actually look at a couple of examples here that actually illustrate how we can use this to help us. Okay. So in this case, example 2 is actually a real world example. So it's going to be a little bit of a word problem here. And in this case, we're going to apply properties of numbers. Okay, so they tell you this question has to do with party planning. Okay, so they say Eric makes a list of items that he needs to buy for a party and their costs. Find the total cost of the items. So the table that he made was, he had the item here. This is going to be a bad looking table. So in first column, he has what the item is. And in the second column, he has the cost of each item. Okay. So in this case, we've got balloons are $9.75. So you got a pack of balloons. It costs $9.75, $9.75. The decorations he got, or the decorations he needs, cost $18.50. The food he needs for the party costs $53.25. And the beverages he's going to get cost $22.50. Now, there's actually nothing stopping you from going over into your handy dandy calculator and just adding all these numbers together. But, okay, so what we would be doing here to find the total cost of the items is we would just add all these prices together. But the way the commutative and the associative properties can help us here is we can actually do this without a calculator. Okay. So in this case, we want to add all these numbers together. Once again, simple way would just be go and add them all together in a calculator. But if we're smart about it and use the commutative and associative properties, we can rearrange these numbers and do them in a certain order to make it easier for us to do the calculation. Okay, so what I mean by that is, first off, let's use the commutative property. We see all this is addition, so that means we can move the numbers around however we want to, and the answer is still going to stay the same. So I'm going to put the $9.75 first, and then I'm going to move the $53.25 to the second spot. And then I'm going to have the $18.50 to the third spot and the $22.50 in the fourth spot. So all I basically did was I switched the $18.50 and the $53.25. And once again, that's using the commutative property. Okay. So now, if we actually did order of operations, we would do 975 plus 53.25 plus 18.50 plus 22.50. But what we can do is then use the associative property to tell us, well, let's go ahead and add these two numbers together first. Then add these two numbers together. And then let's add their result. Okay. And if you're still not sure why we're doing this, I'm going to show you right now why this makes it a little easier for us. Because now, if we use the associative property and we have to do 975 plus 1320 or 53.25, well, you see 75 cents, 25 cents. We know that's going to give $1. Okay. Well, we have $9 plus another dollar. That's going to be $10 plus 53. So in my head, I was able to add these two numbers together and see that this was going to be $63. Okay. Same thing with the $18.50 and the $22.50. We can see the 50 cents and the 50 cents will make $1. Okay. And we can either add that to the 18 or the 22, but we can have 18 plus 22. We know that that is, well, 2 plus 8 is 10. That's going to be 40. Okay. So 18 plus 22 is 40. And we add another $1. So that means the cost of those two items are going to be $41. And now, once again, without going through and having to put it into a calculator, 63 plus 41, 60 plus 40 is 100, 3 plus 1 is 4, so this is going to be $104. And like I said, we could have taken the easy way out and just added all this together. And if you'd like to double check and plug this into the calculator and double check and make sure you get 104, that should work out. But like I said, we can use the commutative and associative properties here to switch numbers around and group them together or associate them together to make it a little bit easier for us. So like I said, we could work something like this out without having to use a calculator by using the associative and commutative properties. Okay, now the last example for this section, we're going to look and use these properties again. In this case, we're going to be using it in terms of multiplication. So example 3. And this one says use multiplication properties. So what you're asked to do here is evaluate 5 times 7 times 4 times 2 using properties of numbers. And we need to name the property used in each step. Once again, there's nothing stopping us from going and doing 5 times 7 times 4 times 2 in our calculator, okay? Calculator makes this super easy, but once again, let's do this without having to rely on a calculator, and we can make this easier for us by using the commutative and associative properties. So the first thing I'm going to do is when I look at these numbers, I can see automatically, well, I have a 5 and I'm multiplying a 2. Well, so what we can do is we can use the commutative property to rewrite our expression as 5 times 2 times 7 times 4. Okay, so this is the commutative property that allows us to do that. Allows us to move the numbers around, to flip the numbers around, okay? Well, now we can use the associative property to say, well, I want to do the 5 times 2 because I know that really easily off the top of my head. And 7 times 4, that's pretty easy to do in my head. So we can group those together by using the associative property. Okay. And now, at last, we follow order of operations. We need to do 5 times 2, which is something we all should be able to do in our head. That's 10. And 7 times 4, that one's not as easily able to do in your head, but if you know your times table, 7 times 4 is 28. And now we've got a number, 10 times 28. Well, if you know about multiplying times 10, this is going to be just 280, okay? And once again, technically what we used here was substitution. And then substitution again. But once again, we were able to group the numbers together in a certain way to make it easier for us to do this calculation in our head, okay? But like I said, there's nothing stopping you from, if you needed to actually evaluate this, doing 5 times 7 times 4 times 2, okay? If you actually did it out this way, 5 times 7 would be 35. 35 times 4 is 140. And then 140 times 2 would still give you the 280. But examples 2 and 3 here are showing you how you can use the commutative and associative properties to rearrange the terms and group the terms in different ways to where you can multiply them or add them together in a little bit easier way. And then you might not have to rely on a calculator. Okay. Now that's it as far as the examples and the notes for this section. So my suggestion to you is to have a copy of the notes available so you can go and look at each of the properties, because when you do the practice and the homework, I'm going to go ahead and tell you the practice and the homework, they don't really work like the examples did, like we just did in the notes. They're just going to be asking you to match what property matches with what expression. Okay, so you're going to be given a list of properties and you're going to have to match which letter matches with the correct property. So that's where the notes or the properties come in, or you can look in the book as well. So the properties in the book, you can use the book, but make sure you go through and you know what each property is by name, so that way when you're looking at it in terms of the examples or the expressions there, you can match them together. Okay, and that's how the practice and the homework's going to work. But as always, if you do have any questions about what you're doing with the homework or practice, or if there's something that I talk about in the notes that you don't understand, please email me and let me know. Okay, like I said, this is a tough section in terms of it's a lot to remember. But like I said, if you go through and you listen to what I've said about each of the properties and certain words to think about there, that will help you understand what the properties are and how to use them. Okay. But like I said, if you do have any questions, let me know. But other than that, good luck with the practice and thank you for watching.